In this question, you need to understand first you have to write the statement. Statement is a 1 mark, and is in the proof you have to write 3 points: point A, point B, point C. 1 mark. Conclusion also 1 mark, and figure 1 mark. Total 6 marks, and tag problem 2 marks. Statement. So what statement you have to write? Law of conservation of energy. Energy can neither be created nor be destroyed. So this is the statement of law of conservation of energy. Total energy remains constant. Total energy remains constant in a given system. So also total energy is equal to potential energy plus kinetic energy. Consider a freely falling body. A freely falling body of mass m and released from point A. Consider a freely falling body. This is freely falling body, and this is point A at point A. Now this is released from point A. Okay. So when I released, before releasing, so now I consider this is the ground, and from the ground to the mass of the body, this is the height. From the now we are going to derive total energy equation in the terms of potential energy and kinetic energy at point A. So let us see at point A what is going on. At point A, the ground, and from ground to mass m, the total height is h. What is potential energy formula? mgh. So in this potential energy, I want to know what is m. M is mass of the body. G, acceleration due to gravity is plus g. So that is the reason why here it is the small g. And h is height from the ground. So this is equation number 1. Energy formula. What is kinetic energy formula? Half mv square. So in this, we know already m is mass and v is final velocity. So at point A, initial velocity is 0 and also final velocity is also 0, because it doesn't traveling anywhere. It is not falling now. Just it is at a point A. Initial velocity, final velocity both are 0. So when I substitute final velocity 0 in this kinetic energy formula, kinetic energy K is equal to half m into 0 square. So that is equal to 0. Ke is equal to 0. This is equation number 2. So from equation 1 and 2, can I write the total energy is equal to potential energy plus kinetic energy, that is equal to potential energy is how much from equation number 1 mgh plus kinetic energy is 0. So now total energy is equal to mgh only at point A, right, point B. So see this diagram. So from A to B, suppose it coming from A to B and it displaced here to here. This displacement I write x. X is what here? Displacement. Okay. So this is at B. When it is at B, body, what is the height of the body from the ground? So this is actually capital H is the total height, and from that the displacement I am removing. This is the new height of the body at B. Height of the body, height at B, H is equal to H minus X. Okay. So now you know potential energy formula mgh. So in this I want to substitute H value, that is equal to mg. H value is H minus X. Can I write mgh minus mgx? Yes. So this is the potential energy. Now let us consider it is equation number 3. So do you know what are the unknown factors here? You know m is mass of a body, v is final velocity. So in order to know the final velocity, I use one more formula, v square minus u square is equal to 2as. By using this formula, I will find out what is v is equal to. So u is the initial velocity, that is 0, and 2 is constant. A, acceleration due to gravity, is plus g, and s is the displacement. A to B, the displacement is x. All these values I will substitute in the v square minus u square is equal to s formula. Now v square minus 0 square is equal to 2g, displacement is x. Now can I write v square is equal to 2gx? Yes. So this v square value I will substitute in the ke. Now ke is equal to 1 by 2 m. Instead of v square, can I write 2gx? Now 2 and 2 cancelled. mgx, kinetic energy formula. I got it now. So let us consider it is equation number 4. From equation 3 and 4, you know, in the equation number 3, that is mgh minus mgx, and kinetic energy value how much? Plus mgx. So minus mgx plus mgx will cancel. Now the remaining total energy is equal to mgh at point B. Now see, this is the at point A, the body, and now displaced x distance from A to B at B, and now it reached to the ground. Finally it reached ground. So when it reached ground, is there any height from the ground to body? At C, at C the height it is 0. At C height is equal to 0. H is equal to 0 at point C. You know why? It reached already ground. So now potential energy formula mgh, I want to substitute the H value. Potential energy is equal to mg into 0, that will become 0. Potential energy is equal to 0. This is equation number 5. Again I want to know that kinetic energy formula, you know, 1 by 2 mv square. So you know mass of the body, final velocity you want to know at C. So that is the reason why I use one more formula, v square minus u square is equal to 2as. In this formula v we need to find out, u is equal to 0 and a is equal to plus g, and displacement s is equal to what? So from A to C the total traveled distance or displacement is height. So can I write displacement is equal to h at point C? Yes. Displacement s is equal to h. Now I will substitute all these values. V square minus u square is equal to as. So v square minus 0 square is equal to 2g and s is equal to h. Now I am going to substitute this v square value in the k is equal to half mv square. So ke is equal to 1 by 2 m. Instead of v square I am going to write 2gh. So in this 2 and 2 gets cancelled, mgh, kinetic energy. So this is the equation number 6. From equation number 5 and 6, and total energy P is how much? The equation number 5 it is 0 plus kinetic energy is how much? mgh. So total energy is equal to mgh at point C. So what is the conclusion here? From point A, B and C, it is clear the total energy is always constant. It is clear that the total energy T is always constant. So hence the law of conservation of energy, the law of conservation of energy is proved.